of the recording.
So last Thursday, we discussed the derivation for this tree. That we discussed the arrow notation and how we came to this tree, right? Using the theorems for merge and move. There's two cases for merge and one case for move. So we also talked about the tractability of a system like this, which just means that it has a finite amount of steps and it can be derived, right? So now we're going to move on to the actual method that we would be coding for a parser like this. This doesn't need to be, this isn't the most optimal system, and it doesn't need to be like this either, but this is just one approach that's just based on applying the rules in every possible way until we arrive at a success, or as many successes as we arrive. And so a success is just like a successful parse. You can think of it as like a language recognizing the grammar that we produce. So we have a finite state automaton here. The double circle just represents that this is the starting point. So this is how we track the temporal sequence, but what we mean by this is just eso es importante.
Eso no es tuyo.
Sí.
Yo ni siquiera lo veo.
So yes. Esto acá. Lo que importa es lo violeta, los anaranjados son líneas. And we're going to keep track of this using pairs. So from 0 to 1, we have a thread. So we have whatever is in between 0 and 1. When we go from 0 and 1, we have it. So we have thread there. From 0 to 0, we have nothing, which is just empty, right? And we'll show you how we represent that here in a moment. But this is essentially how we're going to keep track of what is being pronounced. And yeah.
Oh, okay.
Does that make sense?
It's okay. I'm totally lost, so it's fine.
So
No, I don't know what you're doing there. Yeah, just keep going and I'll get it, I think. Keep going.
the reason we're doing this is so we can index it in this matrix, because this is what we're
What's
going
the
to
use of the matrix?
Yeah. Sorry.
What's the use of the matrix?
Oh, this is a way to represent the derivation.
Okay.
So you're going to see at the end of this, we're going to have the derivation here.
Okay.
Yeah.
Okay.
It's going to be on the last column.
Is that matrix in one of the slides so that?
Yeah, it's in one of the slides.
Okay, because if you're discussing it, probably since Fernando cannot see that,
Oh, okay.
but
So
it's, yeah.
yeah,
okay,
this is the
okay.
matrix that we're talking about.
That is
So,
the matrix, yeah.
like I mentioned previously, the temporal sequence, you can see it in this matrix. So if you notice, from 0 to 1, right here, from 0 to 1, we have John. And where is that? John is the determinant that has a minus feature. So we have it in this location in the matrix. And Will, we have it in 1, 2. If you recall from the finite state automaton that I just showed you, that is exactly what we're representing here. Okay?
Yeah.
So that's the idea. John will eat the cake. Cool. The double colons will mark lexical items, and the single colons will mark derived items. Right now, we don't have any derived items here, but we'll eventually have derived items in certain places. That's right. Como.
Está tratando de conectarse a la posibilidad, pero.
Pero si tiene una conexión a
Porque.
Exacto, tengo
No,
pues, yo creo que la presentación es más importante, tiene más información.
ok. Entonces, una 4 no sé, pero por lo menos puedes dejarlo abierto.
Pero yo creo que si tiene eso no puedo presentar. Que yo-
No, yo lo quité.
quiere conectar la lana fácil como todo el día de hoy.
Vamos a ver si dice. Sé que a nivel infierno definitivamente está sembrado con intención. Porque ustedes por estado contable, no con una fertilización.
Yeah. ¿Cómo va? ¿Quieres volver a la that's an input.
Sí, el control remoto de la fertilidad siempre desaparece. No sé bien cómo lo
Okay, there. Ya está abrazado.
sí. Ok. Soy Fernando con un lapso mío.
And so along the diagonal, we have the empty items. So in the finite state automaton, 0, 0. Okay. 0, 0 is empty. There's nothing in 0, 0. Well, how we represent that in this matrix is that this empty lexical item can take any lexical item. It can become any lexical item. You can imagine it that way. That we have in our lexical array. So what do we have in our lexical array? Exactly this. We have these items. So we're going to fill the diagonal with these empty lexical items. And up here, like I previously mentioned, in 0, 1, 1, 2, 2, 3, and so on, we have John will eat the cake. So this is what is actually being pronounced. And these are just the empty nodes that connect it. Does that make sense?
Yes, I'm just, again, I'm struggling to see why we're doing this. Like, what's utility and like.
The utility for this is to have a representation that we can code that we can prove is correct for the derivation. So we just want a system that we can prove is correct for this derivation. A parser, really. This is really a parser.
Okay,
And we're going to use the operations that we previously defined.
is this what will be going on behind the scenes in all parts?
Yeah, not necessarily ours, but this is just an approach we could take.
Okay,
Yeah.
Okay, so
And this corresponds to the lexical categories.
if they
And
so I understand, okay, what I understand is that the diagonals, the diagonal, okay? Actually, we have this, it represents all empty.
Our lexical array. Oh, but yes, they are.
Okay.
but what you have, for example, in 0, 1 is the lexical category. Is
Okay, so from 0, 1, if we go back to the automaton that we previously defined, from 0, 1, what we see is Fred, right? That's what we pronounce from 0 to 1. And in the same way, in our matrix, in 0, 1, we find that we have a determinant, which in our case is John, that has a negative feature requirement. Yeah, so that's how we're representing that. Does that make sense?
okay. Yes.
Okay, so the boxes in the diagonal, they all have the same labels. It's like,
Yeah.
okay, so and it's because they are the empty elements.
Yeah.
Okay. Why is n empty here? That n, it's
What a
the T and C, I know, like, whether, yeah, these are empty, but it's what the sentence is Fred will indicate.
Yeah, Fred will eat the cake, but that is in 0 to 1, 1, 2, 2, 3, 3, 4, and 4, 5. So the sentence itself is just from here, from 0, 1 or sorry, I guess what is being pronounced is from 0, 1 to 4, 5. The empty nodes between it is from 0, 0 to 5, 5. So the diagonal essentially.
Okay, but, oh, good, go ahead.
I would do another example, but then tenía que ser la pizarra and it's kind of like.
Okay, okay.
This will make more sense, but the reason we're arranging this in such a way is because we defined a merge theorem for adjacent terms. So we can have adjacent terms in this matrix. We can also have non-adjacent terms. So we're gonna have to define a third operation for merge. It's kind of the same thing we've been doing in the derivation, where we have a minus f feature that needs a plus f feature. That's the kind of the selection requirement. And that's just going to be merging non-adjacent elements. And we're going to keep track of that with the features that we previously defined, minus f plus f. I think another way of looking at this is merging an element that's moving. Yeah, so that's the other operation that we're going to do here. Like we previously mentioned, the operations of the grammar are applied to fill in parts of the upper half of the matrix. What is the upper half of the matrix? That is, the fifth column is what we're going to fill. So the fifth column is what we're going to fill with essentially what we derive here. And the entire derivation is going to be on the fifth column.
So every time you add something to a column, to a row.
It's like a step in the derivation.
And at the end, everything should be on the fifth column.
Exactly.
Because there's 5 elements.
Exactly.
Exactly.
So, and now we're going to do the same derivation, but using this system. This looks very complicated, but I'll first explain what this operation means. So if you imagine that we have x, y arguments, and we have some z output. So you can imagine this as the inputs. So in this case, 4, 4, and num is one of the inputs, and the other input is 4, whatever's in 4, 5, right? The two inputs, whatever's in 4, 4, whatever's in 4, 5. The output, as you can see, it has a semicolon because it's derived, is what we're going to now put in 4, 5. Does that make sense?
If you do the table first, and then from that we go to this other one.
And
With that-
the lady with the
Well, we
calculator
construct a table
symbols
from.
appearing in the back.
Oh, you know what? There's actually something missing here that I could add. So, like we mentioned previously, from 0 to 1, we pronounce Fred, right? So we can start adding our D that has a minus TBP requirement, and so on, right? This would be, so John, Will, this would be Will, so we have a verb that has a plus TBP and a tense. And then we have eats, which requires 2 determinants, so this is a verb, it's equals the B, right? Equals the verb.
Yeah, John will eat, and then you have
Then we have the,
which is the determiner that has the
exactly.
number requirement, and Kate, which is the noun that has no requirement.
Yeah.
That's what it said.
Exactly. Oh, actually, this is.
Para refrescar,
I guess it's
el igual es para decir que va a tomar eso, que eso es lo que necesita, ¿verdad?
sí, el igual es un selectional feature.
Eso es los trigger features, básicamente.
The triggers.
Okay. So now we have Fred will eat the cake. This is part of step 2. This is building the matrix based on the finite state automaton that we built. Does that make sense?
Lo que está haciendo es como que para coger otras palabras que caigan en el mismo, además con la misma categoría, ¿Se trata?
No, yo creo que es para construir la estructura de esa oración. Sí, sí. Pero, por ejemplo, ¿cómo seguiría llenando la matriz?
Okay, pues, for example, what could we start off doing? Sabemos que we have, what we select that? So in 4-4, we're selecting for an n, right? So we want an n. And we have an n. We have an n in 4-5. So we can do this operation. This would be our inputs, right?
That's the 4-4 and the 4-9 and the 4-5.
Exactly.
Why is it that everything that what's on 0-0 is on 1-1 and on 2-2 and on
Okay,
3-3
yeah.
and on 4-4
Sure,
and
sure.
on 5-5?
Yeah, the diagonal.
These
Yeah,
are,
why?
so if you notice in this automaton that we have here, from 0 to 1, we have Fred, yeah?
Right.
From 0 to 2, we have Fred will, but from 0-0, we have nothing, it's empty. So how do we represent this in our matrix? We just represent it as this has all of the lexical features in our array. So sorry, all of the features in our lexical array, yeah.
If you go to the tree with the arrows or anything, so you can see, you will see the empty categories is that, for example, the C, you see the C at top, that's an empty category, okay? So that selects a T category, and that's actually the first thing in the zero box. Huh? And then the number, it's like you see on the bottom there. Yeah, you see the E's are the empty categories. Okay, C is empty, number is empty. Those are the categories that are in 0-0. Okay, and then they are in all the diagonal boxes because
These are the operations that we can do, essentially.
okay, because those are the okay.
Wow.
And this diagonal will remain the same, but this essentially represents all the operations that we can do because it's in our lexical array.
But only the empty ones are there.
Yeah, only the empty ones. Yes, only the empty ones along the diagonal. Everything else is what is actually in our lexical array. So John and so on.
What you
sorry,
mean in the
Fred.
lexical array mean that they are they are
They're features in our lexical array.
Okay, because
Exactly.
basically, okay, technically everything is going to be in the lexical array, otherwise it wouldn't be in the tree.
Yeah,
But it's but those are the elements actually that are visible
exactly.
to the parser.
Yeah.
Okay, so empty categories are not visible for the parser because they're not in the input. Okay, they're not in the input. Okay, so those are in this case it's the category C and the category number. Okay,
Right.
so and what you have in the diagonal is the selection of features, you know, for C and the selection of features for num and category features. Okay, so that's what they. And then since you're using merge, you're starting bottom up. Okay, that's why you fill the how do you say 4 4,5. Yeah, that's okay. So okay, so it's because that's K, no, and that would be the merge with
It's an adjacent merge between these two. Yeah.
with these two. Okay.
So we don't have any problems. So does that make sense?
It might be that I'm just, part of me being fried. That I'm not exactly getting, plus this is a little bit, like I get exactly what's going on 0-1, 0-2, 1, 2, 1, 2, 3, 3, 1, I get that, that's what we talked about last time. It's just that what's below, I don't know why it has to be there, right? Like,
That's the representation we're choosing for this. So right, because in 0-0, it's empty, nothing's being pronounced. So we just represent this one.
Well, the states in an automaton, states are not associated with symbols, so it's transitions. So Fred is not in
Exactly.
0, Fred is not in
Oh,
1,
yeah,
Fred's
yeah.
in the 0
Sorry,
and 1
that might have
transition.
been confusing. What I
Yeah.
mean in 0 is 0, 0. So we're going from 0 to 0.
Oh, okay, yeah, so that's the transition from 0 to 0,
Exactly.
which it's not existent because of the loop.
Exactly.
Okay.
You stay the same.
So
Whereas 0 to 1,
that it's Fred.
You're going
Okay,
to Fred.
because
Exactly.
yeah, you see the lexical items, are read in the transition from one state to the other.
Yeah.
And how is one-to-one?
One to one,
Empty.
there's no
1 to 1 is exactly the same as 0 to 0. It's just empty.
and
There's-
2 to 2.
Okay, so why is one-to-one the same even though Fred is already there on 0?
No, Fred is not already there. If Fred was already there, it would be 0 to 1.
Yeah,
We
Fred,
need the transition. That's how we represent it.
you see, Fred is in the transition between 0 and 1.
Exactly.
Not in
Between
the,
the transition.
it's
not at one.
in the transition between 0 and
Yeah,
1.
but at 1 would need to be represented like this, which is what we have here. A 1 1 and again. at
1 is, imagine it's like a loop that goes from 1 to 1.
Exactly.
And does nothing.
There's nothing there. There's nothing from 0 to 0.
Is there
there's nothing
ever,
from 1
is
to
there
1.
ever a scenario where there is something there?
Not really, not here. Okay.
But
They
why-
might, you can have loops, but
This would be 0 0 this loop. 0 to 0.
Yeah, I get that. I get what you're doing now. That's 0 2.
And this would be, yeah, this 0 to 2
that'll be a 0.
is AB. We don't have AB here.
Exactly.
At 0 0, we have nothing.
No.
So 0 to 2 is.
If you were to have that, it will read the symbol from 0 to 1 or 1 to 2.
Okay,
If you
and
were
if
to
you
have
do
that,
one, if you do 1 to 2, it only reads B.
B, because that is
And
consistent.
A doesn't exist.
No,
No. But we're just,
finite state automaton has have no memory.
So the
So-
only way to get the whole thing is to go from 0 to 5.
yes, that would get you the
Okay,
entire, yeah.
Because 5 is
Final
is
state.
the final, usually the final state is the one with the double thing.
That's not exact, so it's not exactly that. Well, that's why I just marked the start, because the end doesn't really matter.
The end is.
It's just, it's after this. But yes, just think of it as a subsequence of the morphological sequence.
Okay.
So that's the only thing we're looking at.
I am 64.3% of the way there. That's good enough.
Hey,
It's
that-
better than before. Good. Keep going.
Yeah, keep going.
That's good.
I don't know if you might make the thing worse if you keep going. So let's just stay there. Okay.
Okay, so now we have an idea
I'm
for,
just vibing right now.
now we have kind of an idea for why these things exist here. So that was step 2, creating this matrix. So now we have this matrix, we have the pronounced features and we have the empty diagonal. So now we can actually start doing the operations like we've already talked about. We're gonna have the third merge operation, which is gonna be for non-adjacent features. We're gonna see that come in, for example, when we need to do the minus EBP to plus EBP. So that's gonna be non-adjacent, and we're gonna see what we do for that.
It's merging from non-adjacent categories.
Yeah.
Is that like movement?
Yes.
You don't seem too sure when you say
But we
that,
only have,
which makes me confused.
we can think of the third case for merge as movement. Yeah. So like I mentioned previously, this notation that we have here, it's just the inputs on the top and the outputs on the bottom. And we represent outputs with a single colon. Oh, yeah, we represent the outputs with the single colons just to mark the direct. Okay, so how does that take place here? So we're selecting for an and, we have an and. So we'll do that.
Is it big?
Yeah,
That's an big.
and then we fill the bottom feature, and we're gonna fill that with just no, right? So we have the right. Here. This operation has just added a derived num here. And
As soon as you merge noun with the noun, the selection of feature just disappears.
Exactly.
You just keep the category. Okay.
And now we can merge the adjacent determinants with non-lexical items, so that's right here. And we're gonna merge that with this section should have that. Oh, this. Right? Okay. Not like that, right? So again, this is adjacent merge, no problems here. And we're just gonna go to 3.5. And we're gonna add what we just merged with here. Now we have the right key. Determinant.
Yeah, because you have the number.
Exactly, we selected for a number. Oh, we have that, and now we just have B. And that's your next one.
Or backdate.
And the was selected K. And now that's done, so we don't care about that anymore. So that feature is gone. More adjacent. Now we can merge the verb phrase with the determinant phrase. So we have 2, 3. We're selecting for a determinant. Oh, we have one. 3, 5. Oh, we have one right here. So now we can merge that and 3, 5. We fill that with another determinant. They're just like before. We still have a selection feature here. We're still selecting for determinants. So yeah, that's right. No. No, it's right. So yeah, fine. We selected for a determinant. So now we're still selected for a determinant and for a verb phrase. Or sorry, we have a verb phrase that's selected for a determinant. So now we add the right.
If you have a verb with one selection of feature.
Exactly. We have a verb with one selectable feature, and now we just add that to 2.5%. Now we go to the third case of merge, which is essentially movement. Yes. We have a non-adjacent specifier. So what do we do in this case? We keep the coordinates of the moving elements separate because we're going to need them later on. So 2, 5, we're selecting for a determinant, our verb is selected for a determinant. Oh, we have one in 0, 1 with the negative EVP feature. So we can go to 2, 5, and add. So we have a verb. 0, 1. Yeah. Okay.
What phase of the project is this? Is this phase 3 or phase 4?
Phase 2.
The lexicon?
No.
This is not like
Phase 1 is
Oh,
selection. Phase 3. Okay, because like this is not. We're like, what? No.
makes sense.
No. But I'm trying to follow.
Esto satisface esto, ¿no?
I'm getting lost between the colons and the
Porque ya satisface.
Gemini
Ya,
colons.
uno.
So. No, aquí estamos buscando.
De 0 que viene siendo spread, que es el otro.
Yeah, no, exacto. Sí, sí, sí. But we keep track of this because it was not adjacent.
Okay.
That's, yeah, over here.
Y esto se queda como que.
Yes, it's together. The reason that stays is because we care about being able to backtrack the derivation, and that's how we know we have a correct derivation when we can go back and arrive at the original result.
Okay.
Or at the original like initial state. So that's why we're not deleting anything.
Okay.
And moving on. So now we can merge the tense phrase with the verb phrase. So yeah, we have a tense phrase that contains the same moving element, right? So that is here, right? We have a verb phrase, or sorry. Yeah.
You have it.
Oh, sorry.
It's a tense, yeah, it's tense that selects a verb phrase, which you have in 2, 5.
Yeah, I'm just making sure I had it correct. Okay, yeah, so we're selecting for a verb phrase. Yeah, exactly. We have it in 2, 5. We have verb phrase, right there. So Yes. Kind of long, but,
Kind of wrong?
no, it's kind of long.
Oh. Wrong.
Yeah.
This is empty natura. Jesus. I was just
Try to think like a machine.
oh
Yeah.
oh
Yeah,
Easy.
This isn't meant to be done by hand.
Oh.
This is a program, you
It's a
know,
program.
so.
I'm losing I'm losing track of when you stop using double colons and then you go to singleton colons. Why?
Because single colons are elements are
Interpreted? Is it derived the same as interpreted?
Derived, no, derived is produced by a
Yeah.
syntactic operation. It's not like a,
So
like a
yeah.
lexical item. It's something that is derived.
When
something that is
we-
merged, it's like, the product of merge or the
So
product.
when you take two Lego pieces,
when we merge.
And you put
we
them
have the right
together?
item.
Es que fue una,
Exactly.
es una,
left night as well, isn't it?
It's the output of having this merge.
What night? Oh,
pero ajá,
So
es
once-
una, es que fue un output anteriormente.
so everything in double colons are things floating. And then once they're operated on, they become single colon.
Because they are derived syntactic, there's syntactic objects that are the
They
product
don't
of.
actually become single colon,
This is just a presentation.
but we have like. We have an output that has the single colon, which is the derivative.
I feel like you said yes and no at the same time.
Okay, see that, for example, in 4.5,
Uh-huh.
in 4.5, okay, if in 4.5, when you have the merge between the number category and the noun, okay? So, see that the number has only the two, what is it? I go, those one problem?
Uh-huh.
Yeah, okay, because that is a number phrase, that it's the merge of the number category and the noun. Okay, so it's
So what's on the second, on the lower in the cell is actually higher in the phrase,
the low,
right? Yeah, because the number phrase is above the noun.
I think that's usually always true, but you follow the derivation steps.
but it's, yeah, but it's not trying to represent
Yeah.
hierarchy by means of.
But is what ends up happening.
Yeah, because it, okay, because the first thing that, okay, with. I say this.
It's okay.
It's okay. Okay, in 4.4, okay, you see that the number head
Mhm.
has a selection of in n category, n selection of feature.
Mhm.
Okay, yes, that's what you see in 4.4.
Mhm.
Está bien, nos vemos, nos vemos.
Nos
sí.
vemos, cuídate, suerte en los finales, felicidades.
Casi navidades ya.
Esto ha sido,
No se siente, yo veo bien como que no.
esto ha sido bien macro, nada.
Pero todavía me siento aquí en finales y tengo que ver con todo esto. Anyway,
No te preocupes, ya se acabaron los finales. Sí.
nos vemos.
Manifest.
Igualmente.
Manifest. Nos vemos.
Okay. Recuerda que en la transición de 4 a 5 es donde está Cake, que es el sería bueno si viéramos
So,
así que una vez tú tienes ese, por eso es que está el double colon n, ¿verdad? Es que el Cake es el n. Cake está en la transición 4 a 5.
ajá.
Por eso está en el cuadro 4 a 5. ¿Ok? ¿Bien?
¿Por qué num no está en 3-5?
¿Cuál no? ¿Cuál de los números?
El num que está abajo, ¿verdad?
Bueno, porque precisamente ese num se forma cuando haces el merge entre la categoría num que selecciona un nombre, but you have in 4.4, but you have we have the noun in 4.5, okay?
Shouldn't it be like arriba num y abajo de? No?
This is not a tree, okay? So
Okay.
you're not, no, position doesn't mean like
And
Yeah,
that's also why we
like
don't play.
any
trees
kind
here.
of, this is not a tree, okay?
Not a tree.
So, yeah, so, it's essentially what you have in the first line of the box is the category that is merging, right? Merging with, in this case, the noun that is merging with noun, right? So, noun and num, noun in 4.5 and num in 4.4, okay? They merge, and they produce, since the head is num, okay? You have an object of category num. That's a derived object. That's a product of merge between num and the noun case. So you
Okay.
have something of category num that is derived. Derived means the product of the syntactic operation of num. That's why it has just a singleton call.
Okay.
Okay.
And then, so why is D just alone in 3.5? Because everything else is like a
We
part,
derive,
except up until
Okay.
1.5.
We,
we haven't, so I don't know if we actually add anything there, but it doesn't matter. So, like,
Even if it doesn't matter,
Well,
if it shows
eventually-
the process, it'll help me understand.
so you're asking why it's alone right now?
Yeah.
Well, if you notice for all the other ones, so this at one point was alone,
Mm-hmm.
then we derived, no.
So if there were a 6 in like it would be
If-
6.5, I
in
guess, or
3 and
something.
4, you have
Six-
D.
No, you can't.
In 3 and 4, you have the. The is in the 3.4 tag. What is the? The is the determiner that selects a noun. That selects a
Number.
the category number. Okay. So, but you have that category number in 4.5.
Okay.
Okay. So they merge, and then you have the determiner phrase, which is that you have the D in 3.5 with just the singleton column, because that's the determiner phrase, the cake. Okay, every time you do a merge, okay, the label for that merge is just gonna have the singleton column, because that's a derived object. That's not something that it's it's not a lexical item. It's a constructed syntactic object by the derivation. Okay, but now you have that determiner first, okay, which is in 3.5. But you have in the 2 to 3 transition. That's why in box 2.3 you have the verb, and the verb eat selects for two arguments of category D.
Okay,
Okay.
yeah. The
And that
subject
verb
and
is
the object.
that verb is a lexical item. It's not derived. It's something that it's you could just stop me at any time. Okay, yeah, is that?
Yeah.
Okay. So, yeah, but what we already have a D, with the 1 in 3.5. Okay. So that actually, so you can merge the verb in the 2.3 with the determiner in 3.5. Okay. And that's why in 2.5, and when you merge that, you're gonna obtain a new syntactic object of category V, but not with 2 selectional categories, but just 1, because one of them was already satisfied by merging the verb with the object in 3.5. Okay, that's why you have a new syntactic object of category V that now needs to select only 1 D argument. See that? Okay, you see that?
So,
Okay.
Desde la diagonal hacia abajo se usa.
No, no, va a
No,
quedar
no, no.
así, pues, okay, so what happens next, Leo? Now you have that you okay.
Oh yeah, so now notice that we have a plus EBP feature and a minus EBP feature.
Oh, but could you explain that, because I just went to the new constructed verb with one verb phrase with just one selection
Oh, so
category.
you're step 4.
And then, and then we have the verb here. Oh, okay, because you do the second merge. Is that, what is that, the column B 01 minus IPP.
Oh, okay, so. Whenever we have a non-adjacent specifier, we need to not only have in this case, the verb phrase, but we need to keep the coordinates separate for the moving element.
And that is because you say it's not adjacent because the next thing with that D category is Fred,
Exactly.
which is in 01 there, and there is the tense element will between the verb and the determinative phrase Fred. So that's why it's a non-adjacent thing.
If we were looking at a tree representation, this would be kind of moving past will. Exactly.
Exactly. So pretty much what you're doing is reconstructing what would be the original position of Fred. Now, because Fred would have, it has to be one of those arguments of eat, okay? Even though it's not next to eat. And that's and is that what you're keeping track of there?
Yeah. And that's the next thing we're gonna do now.
So that's why it's you see that the category verb, there's a new object of category verb, which has no selection of requirements because it has already merged with the element in 01, which is Fred. Okay, which is Fred. So that's the second merge of the verb. Okay? First with the cake, the second one is with the external argument, Fred. Yeah, see? So now we have the saturated verb. Now the verb has no selection of requirements. It's done. Okay. So then you go to 1, 2. Is that it?
So 1, 2 or 1 or 01?
Yes.
No, we have one.
So we have 1, 5. No, it's gonna go to
1, 2.
what do you mean?
Hmm?
What do you mean? What do you mean?
No, I mean that once you have the verb phrase, okay, that's what you have in 2, 5. Okay. So what do we do now? What's the next step?
Oh, okay. So now we have actually this is wrong.
I think in 5 you meant merge the T with the VP and this from to TP. I think there's a merge it.
Yeah, but I think
Are we in step 5, I guess?
yeah, we're in step 5. So
Okay,
now
so you're merging the T. In the slide says merge the TP. I guess it's.
oh yeah,
merge the T.
that's right. Yeah.
See, again, in slide this TP, it should be merged the T with the VP. Yeah?
So
Or no?
it is the same for us.
Yeah, okay.
At least the book, it treats it as the same. Especially for the arrow derivation that we did.
Well, yeah, the algorithm makes no
Exactly. There's not a
commitment of category level. Okay.
Exactly. It's really just, yeah.
Okay. But in terms of understanding things, is that that's program in 7, for example, you have merged the TP to C. So that's what syntactic, and so it's the same thing with the T.
Eventually, we all get it
Yeah.
at once.
We converge.
We converge.
We're hive mind.
So now we have the tense phrase with a selection feature. It's selecting for a verb, right? We have one in 2, 5, right? We have this. So we can merge this, and in 1, 5 we add so we have the tense phrase that's selecting for a plus UVP, and we have the minus UVP. Yeah. So now we have a visible plus UVP and a left adjacent minus UVP moving phrase. So the DPs are just the determinant, right? We can just say that is the tense phrase that specify a position. So
No es que nadie vio que dijo que piensa que va a colapsar y verifique si estaba bien.
now the inputs are 1, 5 and 0, 1, and we just have the tense
Déjame darle
phrase
una
0,
pieza
5.
de información a Fernando para que se escandalice. Fernando, entregamos la revisión curricular de ingeniería de computadora ayer, pasó por referéndum, se aprobó hoy, se presentó al Comité de Asuntos Académicos, se envió a la Industrial Advisory Board y la pregunta que me hacen es que si esa revisión curricular es para el programa de INSO, el de SIC, el de CICIC, el de hardware, y que si nosotros enseñamos hardware o no enseñamos hardware, porque ellos no entienden la diferencia entre los programas. Tuve que contestar el email ahora.
No worries.
Contestalo diplomática.
Eso mismo traté de hacer. Primero le escribí un mensaje nazi y después lo cambié.
So, para aclarar lo que vamos a hacer. You remember in the tree when we had a plus CPP and a minus CPP, there would be the movement, right? The license that feature. And that's exactly what we're doing here. So now we have that.
¿Dónde estamos? ¿Dónde estamos?
Ahora estamos aquí.
Ah, ok, sí, ya, ok, sí, ya.
Y lo que nos queda, lo que nos queda es ¿qué pasa?
Ahí va a ser.
Sí, aquí va a ser.
No, en 05.
Sí. Wait.
No es.
Ay, esta no es. Espérate.
No, es.
I think this is this.
There's something there.
Oh, no. Es que aquí tenemos el minus infinity. So, we did this weird merge, the third case de merge. Nos quedamos con esto. I think the book uses eventually. So, del step 4, lo que nos resulta es un verb phrase in the temporal 2 to 5, que pues estaríamos aquí en nuestra toma, estamos de eat the cake. Tenemos el verb phrase de eat the cake. Eso es lo que nos da de step 4.
Ah, ok. Es que sí, que te falta un paso.
Pero we're merging with something that's moving. So that's why we keep el 0-1 ahí. And we can just finish that step. Lo que resulta es, so, minus plus CPP times y minus CPP y solamente
Cancel each other.
exactamente.
And now,
Y ahora, lo único que nos queda,
0.
0, tenemos, we're selecting for a time space. Oh, we have one. Lo único que nos queda. And we just add the column like this.
once we get to C, the derivation.
So, funny thing, there's actually something else we can do here, but it's harmless. So, si te fijas, we can. So we can still select another determinant. Que sería, we can do that. Sería T, minus CPP.
And that's why you have what you have in 2.5. Now it makes sense.
Yeah.
Okay.
Pero, no sé nada. It still results in the same derivation that we originally did. Lo único que, but that's just an 8th extra step, I guess we can look at it.
So guys, it's just replacing the, well, as if. Okay, yeah.
Y ahora, we have completed the matrix. How do we know this? We have a clause C that spans the entire column that we were filling. We can backtrack the steps that we did and arrive at the successful like input. So because we can derive the structure, it is correct. So we're done.
Okay. Okay. I guess we should have a quiz at this point. Let's do a matrix.
También el libro lo compara con este matrix multiplication. I don't think that's so clear. So,
Okay.
lo comparan con matrix multiplication,
Ah, okay.
which kind of makes sense, pero
Sí. De hecho, okay. El paso 5.
paso 5.
Sí, no es el tense phrase, el tense with verb phrase. Que era el paso 5 que tienes en tus establishment the tense with the repeat, not the tense phrase. Tense phrase is not there. It's actually like that in the, so it will forget your type of stuff. It's tense. Merge the tense.
So we're selecting a tense.
No, tense is there. Tense is you're merging it. But you're merging that with the VP. You don't have a TP yet. You have tense. You have TP. Huh? But you don't have, which is will. Okay. But you don't have a TP until you merge it with the VP. Okay. Well.
Sí, pero es por el movement, es por el movement.
Aren't you copying this from this?
Sí. Okay. Yeah, that's okay.
That's why.
No, sí, it's really nice, really nice. So, yeah, se supone que sea, yeah, VB con este.
The Lord have mercy.
You have to do a couple of
Just for fun.
Just for fun. It's just fun. Okay. Let's try this one. Colorín colorado.
So,
Esta neurona se
I
acaba.
mean, not really, no se ha acabado.
¿Qué?
O sea,
¿Cómo que no se ha acabado?
I mean, esto se acabó, tío.
Ya el dijo colorín colorado, no puede terminar.
O sea, este es el end card y después, wow, lo seguimos.
Sí, no. Yo no logré ese
Sí,
it has nothing to do with me. I don't think so.
La promoción no ha salido porque no lo han
No
aprobado.
te he enviado nada todavía.
Yo lo puse a la vieja.
Ok, sí.
¿Lo dejaste?
Sí.
Puse el nombre de Christopher, el
Sí,
tuyo, el de
exacto.
Fernando. O sea,
Sí,
yo no sé ni con qué lo puse. Pero puse un link para que ustedes tengan acceso y esta vez los separé. Los que quieren solicitar el proyecto tuyo los puse en un lado, los de Isidoro en otro, o sea, los separé. Así que tú tienes una tablita solamente con los interesados en tu proyecto.
Ok. Y ya está.
No ha salido.
No ha salido.
Paola supuestamente está faltando y ella es la que aprueba, pero cuando Paola regrese,
Es los carteros.
ya está aprobado.
¿Cómo va a ser? ¿Cómo va a ser?
Ay, Karina se fuera del teléfono. Es la que va a aprueba.
Está bien, pero tienen que aprobarme de mi colegio.
Sí,
de
sí,
ingeniería,
claro.
porque esperemos a que ella apruebe mañana, si no molesta la decana. Pero la realidad es que el va a salir. Y cuando empiecen a llenar, pues, te voy a dar el acceso. ¿Ok?
Ok. Ya estamos en
Sí, si le interesa, this algorithm is correct because every step that we did is finite. I'm not going to get into it, but every step that we did, 4 steps total, they're all finite. Now we go on the garden paths.
Es finito, pero no necesariamente correcto.
Es correcto si al final tú obtienes el singleton column C. Si no tienes eso, ya quiere decir que all uninterpretable features have been erased. So you get a syntactically an interpretable structure.
Pues esta sí es la razón, pero no porque es finito.
No, the fact that it's fine, it makes that it's intractable. It means that the problem is tractable.
Pero eso es un problema del explorer, porque nosotros aplicamos las definiciones de todas las maneras posibles en este algoritmo hasta tener una correcta. Eso sería un problema de que la combinación que tenemos no se puede formar.
Well, if you try, for example, if instead of, how was the sentence? Fred will eat the cake. It will have, Fred will, I don't know, Fred will sleep the cake. It shouldn't converge. Because
Really
sleep,
will reach the cake.
exactly, it should not converge.
Yeah, no puedo
Because you have, what you have what is it? Yeah, in 2, 3, you will have, instead of, equal D, you will have equal D, V.
Pero
Yeah,
no
okay.
quiere decir que se
That the derivation crashes.
Actually, I
de
mean,
Shouldn't it work anyway? Because then you just have a leftover equals B, right? Or leftover D.
But that means that you have an interpretable feature that is not erased.
Okay.
Porque convertir es que se acerca a una condición de la cual
Okay, yeah, but
detiene.
no, that's mathematical convergence. Linguistic, okay, in syntax, convergence means that the derivation succeeds, eliminating all uninterpretable features, okay, and obtaining the highest category, that you need for that structure. Okay, that means convergence. If that doesn't happen, then you have the derivation crashes.
Yeah.
So converge o colapsa.
no podemos producir un parse que va en contra de los teoremas que definimos. So,
Exacto.
por los teoremas que definimos, si creamos una derivación, por ende su representación es que el parse está correcto.
For example, if you had,
Una definición completamente diferente.
sí, no puede ser, no es matemática. Sí, convergence es la que se aproxima a, ¿verdad? Porque yo digo,
Que tiene una
por lo menos, ¿verdad? Como es cada de los límites, eso, que tiene una cuota, exacto. No es, aquí converge quiere decir que en sintaxis, exacto, no es de aproximación.
Pero la matemática es la base de todo.
Yo no odio la matemática. Yo odio como me enseñaron la matemática en este recinto. Es muy diferente. Y yo llegué, o sea, yo estoy haciendo lo mejor para catch up, ¿me entiendes? Y esto en realidad ni siquiera es matemática como tal.
No, en verdad que esto es súper matemática.
Nosotros no estamos haciendo calculaciones numéricas.
Sí, pero aquí tenemos
Eso es matemática, eso es
Lo
aritmética.
que pasa es que la matemática.
Matemática no tiene nada. Tú puedes hacer matemática, no tienes que bregar con números.
This is pretty advanced.
Eso es matemática.
This is proof theoretic. Like,
La
notation.
matemática tiene
Es verdad.
con lógica,
Claro,
es matemática.
no es con sumar, restar, eso es aritmética.
Bueno, pues nosotros trabajamos, somos todos matemáticos.
The theorems we've defined, like,
La
they're pretty.
matemática.
Like, por ejemplo,
Sobraron.
es-
Si sobraron 4, me los llevo, porque tengo visita en casa. Si sobraron 4, si no, porque no voy a dejar aquí.
Es que tengan paciencia, pero ya, prácticamente, yo también estoy un poco una paciencia.
¿Cuáles están? Esos son los que están
Todo
protegidos.
igual que tuyo.
Ok, perfecto, ya, te suelto.
Puedes distribuir. Ajá.
¿Qué pasó?
¿Qué pasó?
¿Ah?
This is very intense. Like, someone with no mathematical background does not understand.
I'm trying, and I understand that.
Yo tengo matemática de background y se me hace difícil. Es
Bueno, sí, porque tiene las
Yo-
dos cosas, ¿no?
Déjame, el problema mío con muchas de las cosas que estamos haciendo, y yo creo que es un problema que es que como se enseña la matemática en general, es que simplemente te enseñan el proceso de cómo hacer las cosas y no el por qué lo estamos haciendo.
Yeah.
Yo no entiendo, porque yo para que aquí en matemática.
De acuerdo a Michael, eso no es enfoque matemático ahora mismo aquí.
¿Quién es Michael? Michael. Está hablando de otra persona.
Clase con.
Por eso yo no tengo queja de mis matemáticas ahí.
Pero esos profesores están aquí ahora mismo.
Bueno,
Texto, yo me daba una derivada, me enseñaban una derivada en una aplicación.
Eso ya es, a mí lo que me enseñaban cuando yo era estudiante aquí
Primero me enseñaban
en el
derivada
2000,
y después me enseñaban
En el 2009 y en el 2010, esta es la fórmula. Tienes ahí tu calculadora gráfica. Pon la- Bueno, entre ellas fue aquí, fue.
Es que yo creo que cálculo es bien malo aquí. O sea, no te enseñan los teoremas en realidad, que es lo más importante, como que para poder aplicar.
Y después uno, después te enseñan algo nuevo en el examen que uno no practicó y que uno no tiene la fórmula, entonces crash.
Pero tú, no, eso no es cálculo, estoy hablando de precálculo.
Sí, eso da para cálculo para mí. No, yo no llegué a cálculo. Yo cogí razonamiento matemático y esa clase sí yo la entendí. Pero yo no me recuerdo con quién fue.
Yo tuve que aprender matemáticas.
¿Quién fue que me lo dio?
O sea, no, mis profesores no necesariamente enseñaron.
Ese es el problema. Porque si uno está cogiendo una clase, es para que el profesor esté ahí de recursos para enseñar.
Correcto, pero si fuese por eso, hay muchos conceptos que yo no sabría.
Ese es el
A mí,
problema.
a mí me enseñaron el pensamiento estratégico y lo tengo que usar, así que tengo que de alguna manera aprenderlo.
Y yo llegué a este recinto y sabiendo lo que era el cuadrado.
Por eso no es un problema de recinto.
No, pues me pusieron el precálculo en vez de prebásico. Quedó, que me metían en
Porque ¿a qué departamento tú solicitaste?
y con. No, porque yo estuve. No, yo llegué a la primera clase que la cogí.
Fernando, no nos tocó.
Voy a,
La primera,